Hello everyone, my name is Anton Pelcher. I'm an engineer and I've been building fish farms for more than 10 years. Today we're going to talk to you about media, one of the main elements of biological water treatment at a RAS farm. I think it's a very important topic because there are a lot of rumors and speculations around media, which is better to use, which is not worth to be used at all, what types of biofilter to select. Today we're going to talk about media. Finally, I hope I will close the chapter on this issue. Make sure you watch this video to the end, because first of all, we're going to understand what media is and why it's needed, for those who haven't encountered it before. Secondly, we will consider the types of media which are currently on the market, at least in my country, Russia, the CIS and European countries. And as a bonus, I will tell you about my top 3 types of media that I use or recommend to use at the farms. And as usual, I have also prepared for you a special bonus, which you can download following the link after watching this video. So we won't be running ahead. Watch the video. Here we go. Let's start with the question why media is needed. In its vital processes, fish eats and emits impurities. There is suspended matter, elementary dirt, residues of uneaten feed, feces, which can be detained by the drum filter. There are some microorganisms, pathogens, bacteria and viruses that are killed by means of disinfecting units. And there are also dissolved impurities, actually that's ammonia, NH3 and NH4, which make for the total ammonia nitrogen that fish excretes during its life cycle, usually with urine. It cannot be trapped by either drum filter mesh or ultraviolet disinfection lamps, nor partially by ozonation units. Therefore, the only true and reliable way to treat water from ammonia, which by the way is toxic to fish when exceeding a certain concentration, as fish feels bad and then just dies. That is, RAS can't operate well without it. That the only way to remove ammonia from the system is water biological treatment. I think many of you know what biological treatment is. If you know it already, hit the like button. So, what is water biological treatment and what is its function? It converts ammonia first to nitrite NO2 and then to nitrate NO3. Nitrates are considered to be a relatively harmless form of nitrogen and are safely flushed out with the makeup water. So, to make this biological treatment work, we need bacteria in RAS. And that's why this type of water treatment is called biological, because it's carried out by living microorganisms. The bacteria have to be constantly in RAS. So, the question is, where should these bacteria be located? In the drum filter? In the tanks? No, bacteria has to be fixed in a special water treatment unit, and it's called the biofilter. This biofilter contains a special substrate, which is called media. What is media? There are lots of types of media. This is a special substrate which bacteria are fixed on. What are its functions? Firstly, it allows to fix bacteria at a certain area. Secondly, it can increase this area by dozens or even hundreds of times. That is, it's such a multi-story house for bacteria inside the biofilter. What is the benefit of fixing the bacteria on such a substrate? First of all, it increases the area of the bacteria performance. Tens or even hundreds of times more bacterial colonies can settle on such a substrate in comparison with suspended bacteria. Secondly, it allows bacteria to stick and not to be removed from the system by the disinfection unit, so that they will not be killed by ultraviolet or ozone. So the biological treatment will work all the time. And of course, when all the bacteria are fixed in one facility, it's simply convenient to operate RAS. Let's look at what the media looks like, and I have put together my entire collection for this purpose. Let's have a look at it. Talk about manufacturers, brands, which media is better or worse. Thus we will talk about practically everything regarding the media. Let's go! Dear subscribers and those who watch my channel for first time, I'm used to visiting a lot of RAS farms in Russia, the CIS countries, Europe and other countries, and regions all over the world. And honestly, I take, and I can even say that I steal, samples of media from all those farms. Just kidding now. As a matter of fact, I ask too many questions about these media, but I definitely try to take some new specimen with me and to learn as much as possible about it. So especially for you, I've got my entire collection, and now I'll show you what types of media I have, and we'll go through all of them and figure out what type is better, which is a little bit worse, and I'm sure that you are interested to know. So, first of all, I would like to say that there are a million of media options, which are used in water treatment units in general. It can be both rough and ceramide concrete. It's all types of media, but today we will have a look at one type only, which is the most suitable and compatible with RAS, and it's fixed bed. That is the type of media that we are going to talk about in details. The second point, there are different options in terms of media density, fixed, sinking, meaning that the first type is fixed on the surface, the second is in a neutral position. The third settles on the bottom. We will talk about them separately. First, we are going to talk a little bit about other things. Imagine that you have a biofilter. It is 1 cubic meter of bacteria settled on the entire media surface. The more bacteria colonies can settle on this media, the better it is. This is called the surface area. This one type of media can have the surface area of 300 square meters per cubic meter, and the other can have 1000 square meters per cubic meter. 1 cubic meter here, 1 cubic meter there. And the difference is up to 3 times. This is the first thing that's important to understand. Surface area is measured in square meters per cubic meter. That is, we take 1 cubic meter of media, fixed or sinking, and this will be the total surface area per cubic meter. This is the first thing. Second, there is a total media surface area, and there is protected surface area. What is total? Total is the total factual media area. The protected surface is the area that is not subject to abrasion. Media inside the biofilter tends to rub one piece against another, and when it rubs, some parts of it become unprotected as the biofilm is simply erased, rubbed off some parts, that is, bacteria don't permanently settle there. This is why media can have, for example, 800 square meters per cubic meter of total surface area, and at the same time only 500 square meters of protected area. And for the calculation of media effectiveness in RAS, we need exactly the protected surface area, so we will take it as a basis. So, what did I want to show you from my collection? Let's start with how the bacterial colonies settle on the media in general. Now I will show you 2 identical media samples from the same manufacturer, possibly from the same batch, but they're different. But in what way? First and foremost, they're different in color. Why? Because this is a relatively new one, and this one I have just taken from the biofilter at this farm. That is, just 5 minutes ago it was still in the biofilter. What do we see? It is covered with microorganisms, which means that it is evenly covered with a brownish film. It should be thin. These are exactly nitrifying bacteria that provide for the biological water treatment in the biofilter. Now let's have a look at the next one. We now see that it's all covered with microorganisms, and there are no white spots on it. This means that in fact the whole media covered area is protected. Why? Because you can see the outer ribs of this media. Even when it wraps, it actually doesn't wipe off all the microorganisms. If you take a plain surface media, these areas will not be protected and they will constantly wear off the biofilm. That's why it's a high-quality media. I will reveal the manufacturing company name later, and I can honestly say that my company makes use of this media quite often. Now let's talk to you about the fact that all is not sun that shines, because there are claimed media characteristics, and there are real ones. For this purpose, I took 2 seemingly identical media samples. This is the Danish one from the Ecoplast, and this is its Russian counterfeit. And you know that my native country is Russia, thus I pay special attention to the media manufacturers in this country. Guys who produce exactly the same media in Russia manufacture it with the same characteristics. Let's compare these 2 types of media. This is the Danish original media. This is the Russian counterfeit. This media is almost the same size, the same quantity per cubic meter, even the number of ribs is the same. But there is one significant nuance that Russian media cannot make such thin ribs as on the Danish one. And here the ribs are thick. What does that mean? Well, first of all, it means that it won't come out cheap because it takes a lot of plastic to make. And secondly, it means that the distance between the ribs is less because the ribs are thick. And nearer to the center the biofilm is coalescing, and there will be much less protected surface area than on this media sample. so this lot will have about 20–30% worse performance than the Danish original. This is one of my favorite types of media, from Helix. This is a German company. They produce really awesome media. At least, we have never had any complaints about their product. It's not cheap. It costs about $850–900 per cubic meter, but it had the highest characteristics in comparison with other commonly used types of media. That is 900 square meters total and 800 of protected area. It's dense, rigid, bacteria grows very well in it. There's all biofilters, which we have filled with Helix media. It's a slightly different model with a small area, about 700 square meters. And surely the customers are happy. Let's move on. There is such a thing as a primary raw material. The media is produced of as well as the secondary raw material. I think many of you have come across it. And if you have, press the like button. And if you have ever heard of secondary raw materials, do that as well, as I'm going to show you some examples of secondary raw materials. What are they? Well, if the primary plastic is produced from a pellet, which comes from the factory, the recycled plastic is a pellet which comes from the recycling of various types of plastics. That means that various bottles are recycled twice, and that's the raw material media is produced of. What are the pros of these media? On the one hand, the second order of media will cost less than the first one. On the other hand, we should keep in mind a lot of downsides and nuances. I'll tell you honestly. We have tried and tested these media at our farms. This lot is made in Belarus. I don't even quite recollect the company name. This media is produced in Crimea, Russia. What are the disadvantages of these media? First of all, it's impossible to get uniformity. Secondary raw materials are different density, different composition, which means that it's almost unrealistic to get uniform density and form, and it's very hard to get it made according to the typical metrics and parameters. Therefore, this media is, so to say, crooked, God forbid. But when you select this media, a part of it turns out to be fixed and the other part is sinking. That's impossible to achieve a normal covered area. Also, as you can see by its characteristics, this media can cover 600 square meters in total, maximum 450–500 square meters of protected area. This one is bigger in size, and it has a significant disadvantage, which is the difference in caliber. There were lots of small-sized media pieces. It kept slipping and penetrated into the pumps, so we had a whole bunch of problems with it. Generally, we could tolerate all that. But there is also a problem that recycled materials often have bad microorganism attachment. That is, our biofilter simply did not start up. It really happened. And besides, recycled materials can smell. That's true. That's why we have practically given up using this media, though it's cheap. And now let's talk about the latest achievements in media manufacturing. This one is called biochips. There are several companies producing it right now, primarily in Europe. It's a soft plastic with micropores, inside which bacteria are growing. This media can have a surface area of up to 5,000 square meters per cubic meter, whereas the most efficient of the conventionally standard media has a maximum surface area of 900 cubic meters, which is 5 times more. What are the disadvantages of these chips? We have been considering and testing it for a very long time. There is a doubt that it will start to be overgrown inside these micropores and thus lose a lot of surface area. By the way, if someone has come across these biochips or has previously used them, share your experiences, as I would like to understand how it performs. If you have actually used them, write how they really operate. This media is of interest in general. I picked it up at one of the farms in Norway when I was there. It's a good quality media, because the whole area except for the outer ring is protected. In reality, I can say that these chips perform well. This is the media that I call freaks in my collection. It's a homemade media of some sort. It is poorly cut ribs produced with the help of a die matrix. It's a round caliber. But even this difference in caliber is not critical. This media turns out to be of the wrong size and shape. So these are kind of freaks that can slip into your biofilter and stop the whole system, as it can slip into parts, get into pump impeller, and so on. Let's now proceed to the surface area. This one has 900 in total. 800 is the protected area surface, and it's produced by Helix. This is also a type of media produced by Helix, but it has a smaller surface area. About 700 square meters total. 650 square meters is the protected area. This one is produced in the Republic of Belarus. I think the total area is 650 square meters. Around 450-500 square meters of protected area. These are biochips with the surface area from 3000 to 5000 square meters per cubic meter. And according to the manufacturer, it's all protected area. This is our K-Plast media, which has the surface of 750 square meters. But the uniqueness of this one is that the entire area is protected. There is no area that rubs off. Another very important point that I would like to discuss is the calculation of the system as a whole as well as media calculation. As if we're talking about it, it's important to understand what to do with it. So, we have a total surface area and protected area. How can you apply these parameters? I'll tell you. It's very important to understand that fish eats feed, releases ammonia, and ammonia treats water of those microorganisms that stick to the media. In what way should the calculations be performed? Firstly, it's important to understand how much ammonia the fish excretes. There is a certain formula. Let's imagine that fish has eaten 1 kilogram of feed. This feed contains protein. Ammonia is calculated from protein, usually from 35 to 55% depending on the type of fish and the stage of growth. We take an average of approximately 40%, and 40% of this kilogram of feed is protein. That is 400 grams, and the protein makes about 9.5%. And to be precise, 9.4% is the ammonia that will be released from 400 grams of protein. So we take 9.4%, but let me round up to 10%. That is 40 grams of ammonia will be released from 1 kilogram of feed. That's just about the average value. And we have 40 grams of ammonia. What happens to it afterwards? Each square meter of bacterial colonies that populate the protected surface area of the media has its own oxidative power. The oxidation capacity of the bacteria depends on the water temperature and, of course, on the fish species. The colder the water is, the slower the metabolism of the bacteria is, and they perform worse. And the warmer the water is, the faster the bacteria perform. In comparison, the difference between the bacterial metabolism of the African catfish and the trout is about 3 times. And as far as the sturgeon is concerned, the metabolism level is somewhere in the middle. For trout, 1 square meter of surface protected area can treat at the temperature level of 16-17 degrees Celsius approximately 0.35 grams of ammonia. That is total ammonia nitrogen NH3 plus NH4 per day. And in order to treat 40 grams, we divide by 0.35 and get exactly the amount of square meters which we need. As for sturgeon, the same bacteria can already treat up to 0.5 grams of ammonia per day. At the same bacteria at African catfish farms, at a warm temperature of 26-28 degrees, can already release about 1 gram of ammonia per day. That is to deal with 1 kilogram of eaten feed. Let's calculate on different species of fish. I'll even take a calculator. For trout, it's about 115 square meters of surface area. For sturgeon, it's about 80 square meters, so it's already less. And for African catfish, it's about 40 square meters. So I need to say, it's about 3 times the difference between trout and African catfish. Well, we have found out how many square meters of media protected area are needed to treat 1 kilogram of feed from ammonia nitrogen, and all further calculations come from this. The rest is very simple. For example, we take 700 square meters protected media surface per cubic meter. And we calculate that for trout. This amount of media can treat approximately 6 kilograms of feed per day. As for sturgeon, such media volume can treat about 8.5-9 kilograms of feed. And on African catfish, the same media volume can treat 17.5 kilograms of feed per day. This is basically all the data you need in order to select the amount of media that you need. Choose it with a small margin of at least 20%. Then you will be sure that this volume will cope with the impurities. Which media do I like? Let's put it straight. If I needed to select media for a farm, I would make my top of which types I would make use of. In fact, that's what we do in principle. If you use it at large industrial farms, you should definitely use biochips, because they save a lot of surface area, but such chips are rather costly. $1,900 – $2,050 per cubic meter. That's a very serious cost. And once again, I would like to reiterate, check with the particular manufacturer that these chips can provide the claimed surface area in reality. And if we consider a more classic one, I would use Helix. It costs $760 – $890 per cubic meter and performs very well. Also, RK Plus media is not bad at all. It costs somewhere around $630 per cubic meter, which is slightly cheaper than Helix. And this is Biromax media. It costs around $315 – $380 per cubic meter. I would use chips at industrial-scale RAS farms. If we consider a more classic system, it would be better to use media produced by Helix. If you need a cheaper option at a relatively small RAS farm, then Biromax produced in Russia will be a good option. As for secondary raw materials, frankly, I would not recommend you to use that, as we have already tried and it was not a successful experience. Yes, there are farms that use this type of media, but we have completely refused this option. So let's resume. My top 3 are biochips, Helix and Biromax. I would probably consider all of them depending on the requirements. It's of course up to you to decide which one to use. To make it easier for you to decide, I have prepared a special bonus for you, a file where I compared not only the types of media that I have shown in this video, but also other types available on the market, the samples of which I didn't have at hand and couldn't show you, their cost, number of square meters per cubic meter, including the protected surface area, meaning their oxidizing capacity. I compared the price, the oxidizing capacity, made conclusions about the efficiency of using these media. And in fact, the efficiency impacts not only the price, but also the amount of air from the blowers, the biofilter volume, and a number of other factors. So download the file following the link in description to this video. I hope you found it useful. If so, press the like button and subscribe to my channel. It was Anton Pelcher and my channel on how to grow fish and make good money from it. Bye!